Good morning, ladies. Happy May Day. We have been talking about human anatomy, and we are focusing in on some of the systems a little bit more than just the general that we talked about with the 12 systems. So today we're going to continue on our same outline because we're still talking about human anatomy. The cardiovascular system was the end of that part one that you had a test over yesterday. And I appreciate the ladies who came in to take the test that missed it yesterday. And I do have those available to you to come take a look at and file in your folder. So today we're going to concentrate on the control systems of the body. So we spoke a little bit about the nervous system before. The nervous system is the fast-acting control system of the body. And as such, it uses electricity to carry impulses. Now, all electricity is the movement of charged particles. So when we're looking at like electricity flowing through a power cord, that's the movement of electrons. Okay, that's what's causing that electricity. In the case of the nervous system, it's a little bit more complicated, but it's the same basic idea. It's the movement of charged particles into and out of the cells. So the basic structures of the nervous system are the brain, spinal cord, and the peripheral nerves. The peripheral nerves are the nerves that radiate from the brain and spinal cord. We're not going to get into the individual structures of the brain and what they do. With all these snow days, once again, we just don't have time to do that. But know that the brain, spinal cord, and peripheral nerves are the structures of the nervous system. We also talked about the cells of the nervous system. So there's two basic kinds of cells that make up the nervous system. One is the neurons. And the neurons, of course, are the actual nerve cells. They're the ones that are conducting electricity. So when we're talking about movement of charged particles into and out of the cell, we're talking about the neurons. The other type of cells are the neuroglia. The term neuroglia literally means nerve glue. And these are the supporting cells of the nervous system. So they're going to support the neurons and help the neurons to do their job. Now remember, going back to neurons, that neurons are unique in that they can conduct electricity, but they're also unique in that they are amitotic. They cannot divide. Once they are fully developed, they cannot divide. But they can make new extensions of themselves to make new connections. We talked about that idea of doing things in a different way than you usually do them, like driving home a different way, or doing different kinds of puzzles that challenge your brain to think in new ways, and that causes these new connections to form. Now, the nervous system has kind of a unique organization, and for this, we are going to, brace yourselves, stray from the outline. So we're going to do this just for a moment because otherwise we would have indents so far over to the right-hand side that we wouldn't even be able to see what we were talking about anymore. And so the nervous system gets its own little outline for organization. So we break the nervous system into two parts: the central nervous system, which is the brain and spinal cord. And the central nervous system's function is integration. So integration is taking two things and bringing them together, right? So we need to talk about what are we integrating. And that falls into the domain of the other part of the nervous system, which is the peripheral nervous system. The peripheral nervous system consists of the peripheral nerves. Okay, so those nerves that are radiating from the central nervous system. The peripheral nervous system is in charge of sensory input and motor output. So if we go back up to the central nervous system and we say it's integrating, that's what it's integrating. It's integrating the sensory input to determine what the motor output should be. So the peripheral is in charge of the sensory input, motor output. Central integrates those two. The peripheral nervous system can be further divided, and you'll see that this is why I have a color scheme going on here. The peripheral nervous system has a sensory branch. This is the afferent branch. This is the part that's in charge of sensory input, so bringing in information about our external and internal environment. And then there's also a motor component. So the motor output, this is the efferent division. The motor division, or efferent division, can further be divided. And this is a term you saw on your RQ for points the other day, into the somatic and the autonomic. The somatic motor part is in charge of voluntary muscle movement or voluntary movement. So your skeletal muscles. So you had that multiple choice question, and one of the answers, there's only one of the answers that dealt with voluntary. All the rest of them were involuntary. All the rest of them were autonomic. Okay. The term somatic means body, and we'll see this when we talk about the reproductive system next week, the difference between somatic cells and gametes. We'll talk more about that. So that means body. That deals with the voluntary. Autonomic deals with the involuntary, so things like digestion, glandular secretions, things like that. The autonomic nervous system can be further divided into the parasympathetic and the sympathetic. Good news, no more divisions. This is our last one. The parasympathetic nervous system is referred to as our rest and digest system. The sympathetic is described as our flight or fight response. So I'm going to start with the sympathetic, even though I have these in the reverse order. I'm going to start with the sympathetic because the sympathetic is triggered when you're feeling stressed. And that could be stress from fear, it could be physical stress, it could be emotional stress. That's going to trigger your sympathetic nervous system to that fight or flight response. It's preparing your body to either fight what is stressing you or to flee from it. So things like increased heart rate, so you're going to get that blood pumping to your muscles so that you can fight back or flee. Things like dilation of the pupils. So your pupils get bigger so there's more light coming in so you can see more acutely. Your lungs are going to dilate as well so that you're bringing in more oxygen because you need that because your cellular respiration rates are going up. This is also what causes like the dry mouth because you don't really need saliva right now to fight or flee. So when you get nervous, this one's kicking in high gear. The parasympathetic then kind of reverses those things. It's a less active system than the sympathetic. The sympathetic is run by, we talk about adrenaline, that kind of thing. It's run by hormones, which we're going to talk about here in a few minutes. But the parasympathetic is more of, okay, calm, just things as is. Now, the thing is that at all times, both your parasympathetic and sympathetic are working together to maintain homeostasis. It's only when you're in those situations where you're feeling that stress that I was talking about, when you're feeling that stress, that your sympathetic kicks in a little bit harder. And so you have all those symptoms, if you will, of the sympathetic nervous system. And then after this situation, so let's say that you're at Duchenne at night, there's nobody here, and a clown pops out at you suddenly. Okay, that might freak you out a little bit. And so your sympathetic's going to kick in high gear. But then after it does that, after you realize the clown is just, oh, Mr. Herbert or somebody like that, and everything's okay, then your parasympathetic is going to kick in to get you back to normal. When it does that, though, to maintain your homeostasis, when it does that, though, it tends to kick you back too far the other direction until your parasympathetic and sympathetic can balance each other out. So, fun stuff. Okay, let's go back to the outline. So the other control system of the body is the endocrine system. Now, the endocrine system, remember, consists of a bunch of different glands that are found throughout our body. And these glands have one thing in common. They all produce hormones. And remember, we said this is the only system that we're talking about in which the organs don't work together. But they all classify as endocrine or as the endocrine system because they produce hormones. So the general function of the endocrine system is it is the slow-acting control system of the body. And so it works using chemical messengers carried by the blood called hormones. And when we think about hormones, usually what we think of are the sex hormones, things like estrogen and testosterone, or we think of, people going through puberty and their hormone levels are changing. And while that is all true, those are certainly not the only hormones our bodies produce. It produces lots of different kinds of hormones. I'm just going to take a look at a few that I think you might find interesting. And when we talk about the reproductive system next week, we'll get into more detail, especially with females, of the hormones that we produce and how that affects us from puberty until menopause. So we'll talk about that and how it affects us at menopause. All right, so we'll start with the growth hormone. The growth hormone targets long bones for growth. So if you remember when we talked about the skeleton, we talked a little bit about that growth plate. So the growth hormone is going to target that growth plate to cause the bone to grow. This is produced by the pituitary gland, which is in your brain. And so if you have too much growth hormone, that causes gigantism. If you don't have enough, this causes what's called pituitary dwarfism. And with pituitary dwarfism, you are smaller, but you have normal adult proportions. I should pull some pictures up for that. All right, prolactin. Prolactin stimulates the production of milk. Now, one of the reasons I put this on here is because, and we'll talk about this more in the next chapter or in the next unit, some hormones we pick up on, subconsciously we pick up on hormonal signals from other people, and prolactin is one of those that you can do that. So if you're around a woman who's lactating, it's possible that you could start lactating as well, even if you haven't just had a baby. So more fun stuff. Calcitonin. We actually have already talked about calcitonin without naming it, okay? So calcitonin is produced in response to high blood calcium levels. And so this is a negative feedback mechanism that we talked about. So if you have high levels of calcium in the blood, that's your stimulus. The response is you produce calcitonin. And what calcitonin does is it puts the calcium out of the blood and onto the bones. So this causes blood calcium levels to drop. And then so the stimulus is gone, no more calcitonin needs to be produced. Now, one of the things we'll talk about a little bit later on is that this whole mechanism is influenced by another hormone that we won't talk about until next week, estrogen. So just kind of keep that in the back of your mind, and this will become important when we talk about menopause. Because in menopause, you stop producing estrogen. Parathyroid hormone. Parathyroid hormone is produced by the parathyroid, as its name suggests, and the parathyroid sits kind of piggyback on your thyroid, and your thyroid's in your throat, your lower throat region. Parathyroid hormone is produced in response to low blood calcium. And so what parathyroid, once again, we have a negative feedback mechanism. So if we have low blood calcium, we start producing parathyroid hormone. And what it does is it stimulates cells to break calcium off of the bone. Okay, so we're going to break down the calcium for the bone. This causes an increase in blood calcium. And then once again, this mechanism is turned off and we don't have to produce it anymore. Now, the interesting thing with this is that parathyroid hormone is not influenced by estrogen. And so when you reach menopause, you stop producing estrogen, which means that this mechanism, this top mechanism, no longer works. It's harder for you to put calcium on your bones, but this bottom one, the parathyroid hormone, is still produced. So you can still break down your bones, but you can't build them back up again. So this is why it's important as a young woman and as you get older to maintain your blood calcium levels. And then once you reach menopause, continue to maintain your calcium levels. Because if you don't, you can break down your bone to put more calcium in your blood, but you can't build it back up. That's why osteoporosis is more common in women than in men. Because they don't produce estrogen, and so they don't have to worry. They're pretty consistent as far as being able to build up or break down bone. Well, there we go. Melatonin. Melatonin is produced by the pineal gland. And remember, the pineal gland is our third eye. Okay. So melatonin is produced in response to light levels, and it helps to regulate our circadian rhythm. So when it starts to get dark, our bodies start producing melatonin, which makes us sleepy. So on days like today, now today's May 1st, 2019, it's all overcast outside. On days like today, we tend to be droopier. And part of that is because our bodies are like, oh, hey, it's dark outside. It's getting dark. That means I need to produce melatonin because it's almost bedtime. Now, we, of course, do lots of things to try and counteract this, like artificial light. You know how much I don't like having lights on in my room, but on days like today, you got to do it. And this is one of the reasons why it's important that you put your screens away before you go to bed. Usually about a half an hour is good, because that light from the screen, your body's interpreting that as, oh, hey, it's still bright outside. I don't need to produce any melatonin. So you can take melatonin supplements to help you sleep. I do caution you about taking those, however, because they can lead to depression. You have to be careful with those. And the last one on my list here, insulin. Insulin is produced by the pancreas, and its job, and I'm sure you've heard about insulin before, its job is to sweep the glucose from the blood into the body cells so that the body cells can use that glucose for energy. So we usually hear insulin in association with diabetes. So there's two types of diabetes, actually. Type 1 diabetes, usually what we consider to be like childhood onset, childhood diabetes, is insulin dependent. So these diabetic patients are not able to produce enough insulin, or they are not producing the right kind of insulin to get the glucose out of their blood into their blood cells. When we talk type 2 diabetes, which is usually adult onset, that is not insulin dependent. You can have type 1 diabetes that's adult onset, but we usually associate it with childhood onset. But type 2 diabetes is not insulin dependent. And that they have found in recent years that we know that there's an association between diabetes when you're older and being overweight, and the fat cells actually produce chemicals that block the insulin receptors, so the insulin can't work right. So that's the story with that. All right, so in a nutshell, this is how your body is controlled using electricity and using hormones. And so today in class, I'm sorry for those of you who are going to miss out, we're going to be doing some work with our nervous system to see how much it remembers. All right. So on Friday, we'll be talking about the immune system. And then next week, reproduction. You know what that means. There's something coming up pretty soon.